Hi everyone. In this video, I'm going to show you how to create a custom Verilog component in P-SoC Creator by implementing a very simple square wave generator step by step. The first step is to create a workspace. A workspace will contain similar library and design projects together. In order to create workspace, we click on File, New option. Under New option, we have the option to create new project. We click on it and then the Create Project dialog box appears. There is an option to select the project type as workspace. Next, we give the workspace name. Now here I'm giving the workspace as name as square wave workspace. Once I give the name of the workspace as square wave workspace, I click on finish. And then we can see that under the workspace explorer, the square wave workspace has been created. Now we add the library project under the workspace. We right click on the workspace name, go to add new project. Under new project, we create library project. And here we have to select the processor based on the P-SoC 5 board that we are using. For CY8C059 kit, we use Cortex M3 as the processor for the library project. After clicking Cortex M3, we go to next. The location of the library project will be predefined by the software. We just need to name the project. So here we name the library project as library square wave. After renaming the file, we click on finish. And now we can see that under the workspace, there is a project named library square wave. Now under the library project, we start making the component, for which we need to go to the components tab. Once we go to the components tab, we right click on the project name. After right clicking, we get the option to add component item. We click on add component item, and then there is an option to create an empty symbol which creates a blank symbol file, and then symbol wizard where we can predefine the terminals we want. We click on symbol wizard and tell create new. Before creating new symbol, we need to rename the component name. Here we rename the component name as square wave gen. After renaming the component name, we click on create new. And then here we have to predefine the terminals of the component. For a square wave generator, we are going to define 3 terminals. One will be clock input, the other will be reset and the third one will be the output. In order to define the terminals, we need to give terminal name and the type of the terminal they are in. Clock will be of clock input. And then we define terminal RST and then give it as digital input. And then there will be a terminal called as out1, which will be of the type digital output. After defining the terminals, we can see that the preview of the symbol is in the right side of the symbol creation wizard. And then when we click on OK, P-SoC Creator will automatically generate the symbol file. Once the symbol file has been generated, we can edit the symbol if we want in order to change the layout of the present terminals. After editing, we can start with the logic behind the component. So we generate a Verilog file which will support the components backend. In order to create the Verilog file, we right click in the symbol file, click on generate Verilog. Once we click on generate Verilog, the item name, that is the Verilog file name, will be auto generated and that should match with the symbol name, and then the destination will be under the library project. And there is this option to create the Verilog file for a target device. The target device can be a generic device or also the specific device that we are using. We want it to be for the specific device, so we give the specifications. Family will be P-SoC 5LP. Series will be of 58LP, and the device that we want to do is LP097, which matches the processor of the CY8C059 kit. We generate the Verilog file, and P-SoC Creator auto-generates a Verilog file. In the auto-generated Verilog file, the terminal defining order should match with the one in the component creation. So we rename the order of terminal definition. First one will be clock, second will be reset, and the third one will be the output register out1. And then there is the comments that tells where to start the body of the Verilog code. So there we start writing the code for the main logic behind square wave generation. The logic is straightforward. I define a 8-bit counter that increments on every positive edge of the clock. Whenever the counter reaches 127, I reset it back to 0 and toggle the output signal. This way the output flips between high and low every 128 cycles, which will produce a square wave. After finishing the Verilog code, we build the library project. We go to build and we build the library project, and we can see that the build is succeeded. Once the build is succeeded, we can go forward in creating the design project, for which we need to go to the source tab. So when we go to the source tab and in the workspace, we right click the workspace name and then add a new project. Now same way in the create project, we select the target device as P-SoC 5LP and the LP097 kit, and we click on next. Here we create an project with empty schematic, and the location will be predefined. The project name, we should be adding the project name here. So here we add the project name as SQ Wave. After renaming the file, we click on create, so that now we can see that the new project, that is a design project, has been formed. Under the design project, there will be one top design schematic file. This is the empty schematic file in which we can add components from the library project. Now in order to import the components from the library project, we need to add dependency of the library project to the design project. So in order to add dependency to the design project, we right click on the design project's name, go down to dependencies. There under dependencies, there is this option of user dependencies, where we can add dependency of library square wave for both components and code. Once we select both components and code and click on OK, now the dependency is being added now, and in the component catalog under the default section, we can see that there is a folder of components where we can have the user defined components from the library project. So here we can see that the square wave generator is already present here. Down we can also see the preview of the symbol. So once we select the square wave generator, we can drag it from the components catalog and place it in the top design schematic file. After adding the component, we then add the other necessary components to the top schematic. First, we add the clock component. So under the systems folder, that is the clock component, we drag and place it in the schematic. And then using the wire tool, we wire the output of the clock to the clock input of the component. After wiring, we configure the clock. So in order to configure the clock, we right click on the clock symbol, and then there is this option of configure. There we configure the frequency of the clock to 1 MHz and then click on OK. After the clock, we then add digital logic low to reset. So we search for logic low, and then we drag the logic low component from the component catalog to the top level schematic and then wire it to the RST terminal. After wiring the reset terminal, we then connect a digital output pin. The digital output pin is present under the ports and pins folder. So we go to the ports and pins folder, drag and drop a digital output pin into the top schematic, and then wire the output of the component to the digital output pin. Once the wiring is done, we then configure the name of the digital output pin by right clicking and then going to configure. There we change the name of the output pin to out1. After this, we apply the changes. After applying the changes, we can then click on OK. Now the top level schematic has been completed. We have added the clock, we have added digital logic low, and then an digital output pin for getting the output from the component. After completing the schematic, we need to assign the output of the component to the actual pin in the P-SoC 5 board. So we go to the pin section under the design project. Once we go to the pin section, the layout shows us green pins and white pins. The white pins are the unassigned ports. So we find an unassigned port and add it to the output of the component. So here we can see that P20, that is pin number 62, is unassigned. So we go to the port section. There in the port section, we assign out1 to P20. Once we assign out1 to the port P20, the total schematic is complete. Now we can go further and build all the projects. So we go to the build option, and then there is this option of clean and build all projects. So there we clean and build all projects and wait for the build to complete. Now in the output, we can see that the rebuild has been succeeded. Since the build has been succeeded without any errors, now we can program the P-SoC board using the P-SoC creator programmer. And then using the P20 output pin, we can observe the waveforms in the oscilloscope. And yeah, this is how we create a custom Verilog component for a square wave generator and observe the waveforms in the oscilloscope.